happy with it. So, shh. First bit. Nothing new here. It's just some terminology, and we're not going to write anything down for that. So for each of the following polynomials, state the degree. Oh. So what's the degree of this? Degree 3. It's a cubic, we say degree 3. Right? It's just how it's the highest one. Highest one, 4. Degree 4. Ooh, don't say it's degree 2. It is. The highest one is 3. So we're happy. Let's skip that. Good? We know how to say the degree. Leading coefficient. Where would we find the leading coefficient? Out the front of? The highest degree. Okay, so if we look at F, 2 isn't your leading coefficient, it's -4 because it's in front of the highest degree. Happy with that? So just terminology. I don't think you need to write down. And who can tell me what is the definition for the constant term? Right, the one who doesn't have a variable. So over here, 7. 8, even though it's out the front, okay? State the coefficient of x squared. Do we really need to do this exercise? I don't think so. Right, what is the coefficient of x squared? 7. What is the coefficient of, let's go with C, of x cubed? It's -3, so don't just say 3, -3. If you ever got a question like that in a test, my God, rub your hands together and go rejoice. Oh, sorry. 0. Sorry. Glasses. I saw that was, I'm trying to find a negative. If it was x, coefficient of x to the 4, right, if it was a coefficient of x to the 4, then it would be -3. Okay, sorry for those on the video listening. Leading coefficient for E? No, it's not 7. 7 would be a constant term. Remember, the leading coefficient is the one that's in front of the biggest power, -1. All right? So little things like that. All right. Question 3 is just a little practice on expanding. Okay? Did we do that? Start of the thing. So you are going to have a quick little recap and be able to expand nicely and double check, because I tell you what, it's really frustrating as teachers when kids get this wrong. We've got 2 options for expanding. Do you guys remember what your 2 options are? So people are saying, yes, FOIL doesn't take you very long. You're just saying everything in here times through by x, then times everything through by -2. Agreed? So we could then say, therefore, P of x equals 2. I'm timesing everything by the x, 2x cubed, 3x squared, plus 4x, take 4x squared, and gather your like terms. And it shouldn't take ages to do that. It should be short, sharp, shiny. Now, very often, when I have to do that, sometimes I've got a cubic that I'm timesing by a linear or whatever. So I have an alternative that I can do. So I'll just show you this. You can go, ooh, I like it, I might use that. Or you can go, no way, Jose, I don't care to bother with that. So, where have I pulled that from? Yep. And then, what's the coefficient of this one? Right, so I'm going to go 1 minus 2, and I'm going to go all the way back to primary school days, and I cover up that one, and I just times all these through by -2. So 4 times -2 is -8. 3 times -2 is -6. I get -4. Do you remember, did we do this at all? No. Okay, good. And then, do you remember your long multiplication at primary school? What do you have to put here? Yes, you cover up the -2. You put a 0 there. You go 4 times 1 is 4. 3 times 1 is 3. 2 times 1 is 2. And then you add them up. So I get -8. I get -2. I get -1. And I get 2. And some of you are going, why? Look at the face. Why is she doing that? Well, constant, x squared, x cubed. 2 minus 1 minus 2 minus 8. Sometimes it's just a quick check that I've done everything right, because I tend to make some silly errors gathering like terms. I'm not guaranteed not to make a silly error using this other method, but it's just a double check. So, don't need to know it, but it's cute. I know my Year 12s use that. So with this one, I would probably choose to do this method here. Oops. Okay. If I really wanted to practice this, it's called synthetic multiplication. If I wanted to practice that, I have to be careful because you have to have everything in your columns. So I would be going 1. What's the coefficient of x squared? 0. So I'd have to go 1, 0, minus 2, 4, and then multiply by 1 and 3. All right, so 12 minus 6, 0, 3, pop my 0 there, 4 minus 2, 0, 1. And so I can now say that this would be 1x to the 4 plus 3x cubed, take 2x squared, take 2x plus 12. Who likes the synthetic multiplication? Some of you do, some of you don't. I'm not going to force it on you. Okay, so take a little bit of a load off your feet there, and can you try and finish question 3 promptly? Love you. We're skipping 4, 5 and 6. Okay, suppose the polynomial has degree 3. Find the degree of q of x. So they're saying p of x is degree 3, so that's an x cubed. What happens when you times an x cubed by another x? X to the 4. So we've got a degree 4. So lots of words. Some students go, oh, it's not asking you for anything major. Are we okay with that? Not giving me a lot today. We've got this one. You can read it. So, Broads, can you tell me what degree would q of x be? It's all right. I'll copy that down. It's all right. I just assume that everyone's happy, but if you're not, then you have to talk to me. So basically what we're saying here is this is x to the 5, and it could have a 7, a 2, a 3, or whatever out the front, any constant out the front. I don't care, right? But we've then got this. I'm just looking at the highest degree. It's x squared. So they're saying this has to be x to the what to make it an x to the 5? 3. So we're just saying q of x must be degree 3. But it's just written funny. Does that make sense? Where you from? So now, what if I said, okay, make this a new question. If I now say p of x now has degree 7 and q of x has degree 1, what would this have to be? What degree would this have to be? X to the what? Yeah, because that's x to the 7. This has to be times x, because we'd say that's linear, degree 1, linear. So wouldn't that have to be a 6? When you're timesing by the same base, you add the powers. It's just indices work. That's all. It's just written to confuse, right? But it's in maths language, and hopefully, Amara, we're going to go, hey, I understand what this maths language is. Okay? We're just saying one function times another function. We all good with that? Awesome. So let's get rid of all of that now. So moving on, we're going to put a little heading, equating coefficients. And then I'll leave you to work in peace in a moment. Alrighty. So when you look at all of that, Who's freaked a little bit? Because there's just letters and numbers and it's all over the shop and you go, rah! Gonna make your life easier, I think. All right. So, can you work out what they have actually done here? Come on, Coops, don't look out there, look over here. What have we actually done? We've got an expanded thing on the left-hand side, and it's partly factorized on the right-hand side. Now, the theory is that if I gave this to you and I said, hey, factorize it, you couldn't do it. Right? How do we factorize a quadratic, Al? How do you factorize a quadratic? Pardon? You don't know how to factorize a quadratic. You do that sum and product thing, yeah. You look for two numbers that times together give you the n bit, but add together give you the middle term, correct? Can you do that with a degree 3, a cubic? You haven't got that anymore. So they're giving you a little bit of a heads up and they're going, okay, I'm giving you part of this factor. If you can use your common sense and work out what this is, then you could then factorize or quad formula this, right? Could you quad formula the cubic? No, there's no formula for that either. So what you're trying to do is break it down to a level that you can then solve. Okay? So all they've done is they've gone, okay, I'm going to expand everything here. And then whatever is in front of this x cubed has to equal whatever's in front of the x cubed on the left-hand side, right-hand side has to equal. Does that make sense? What I'm going to hopefully show you is that you don't have to do all of this work. We're going to reduce it. So if you don't like what I'm about to show you, your option is expand everything and say, okay, 6 has to equal 2a, 7 has to equal 2b take a, minus 19 has to equal the thing in front of x, and the constant is here. Yeah? So you've got a fallback. Well, let's have a look at my version. I hope you'll like it. So please pop this down. Left-hand side has to equal right-hand side. So here, clearly, it cannot be 3x squared and this becomes an 8x squared. They have to be the same. If this is 5x, then a has to also be 5. It can't be anything else. Do we get that? So we're leaping up to, well, what if it's not nice like that? What if we have this kahuna? Well, I think it's the same sort of thing. 2x times the ax squared, isn't that the only way that you can get 6x cubed? Yeah? So are we looking and saying, well, it has to be 2 times a. 2 times what gives me 6? It has to be. A is just 3. So I would like to just straight away go, well, a is 3. If you really want to go and show some working, then you would say 6 has to equal 2a. But I wouldn't even bother with that. I would just go straight to 2 times 3 has to give me this 6. I would also argue with you, or say to you, you should also be able to tell me exactly what c is. Because minus 1 times c, doesn't that give you your constant term? Every single time. It's the last constants that give you a constant term. So what must c be? Has to be minus 7. If you put positive 7, you would end up with a minus times a positive and you get minus 7, and that's not what we want. So it has to be minus 7. We're good with that. So far, so good. Now we've hit a snag. Because how are you meant to get the b? Well, this is how, without having to expand the whole shebang-a-bang. On the left-hand side, I've used the 6x cubed to get the a, I've used the 7 to get the c, so I'm just going to now look at the next one, right? You could look at the minus 19x, but I go, I'm just looking at the next one, right? No right or wrong here. So I say I'm looking at x squared. The coefficient of x squared on the left-hand side is 7. What is the coefficient of x squared on the right-hand side? And to do that, yes, you have to think a little bit and go, well, how? How do I actually get x squared? Well, you get it by saying x times x, do you not? What's 2x times bx? 2b x squared. So, or not to be, that's right. So I'm putting the 2b. Is there any other way that I can get an x squared, expanding that? Yes, Hamish? Correct. So I get a negative ax squared. And we already know what is a? So minus 3. Can you now solve for b? Go through that again. How can I get an x squared by expanding this? There's only two ways, right? I can only get it by 2x, so x times x, that gives me an x squared. And then I can only get it x squared times the constant. If I went minus 1 times the constant, that's no good. That just gives me a constant. If I went minus 1 times x, that just gives me x and not x squared. Yeah? And so now I just solve. Get rid of the take 3, add 3. Get rid of the times 2, divide by 2. So b is 5. Done. Find constants a, b, c. Let's just check. Is that what the example got? Correct. And look at my working. Wow. But if you don't like that, and I was saying before, the first time you do it, you might be going, we'll get a little bit of practice at this. And I can't convince you strongly enough. This is a time saver. So those who want to play ahead, we're going to be doing number 2. I'll be doing it with you, but if you want to ignore me and try yourself, you go for it. All right, find the constants a and b, given the following. So we look. The first thing I'm doing is going, well, this sucker is going to come from the leading coefficients times together in each factor. So x squared times ax, that gives me the a x cubed, and that's the only way I can get an x cubed, isn't it? Nowhere else can I possibly get an x cubed. X squared times x, if I do this x times ax, well, that's only an x squared, so that's not going to cut it. So can I just say a has to be? It's got to be 3. It can't be anything else. If a was 2, well then x squared times 2x gives me 2x cubed. Well, that's not what I want. I want 3x cubed. If a was 5, x squared times 5x will give me 5x cubed. I don't want 5x cubed. I just want 3x cubed. Happy with that? Okay? Oh, disappointed with this, because what would b have to be? Minus 2 times this, that has to be positive 10, so yes, minus 5. If you put 5, you're wrong, because minus 2 times 5 will give you minus 10, and you want positive 10. How sad. I thought that was going to be a good one. Next. Oh, another bit of a pathetic one. I didn't read my own instructions. I think it was question 3 we're meant to do. Sorry about that. It's all right. We're warming up. Okay, who wants to play? What's a got to be? Two x squared times what? X. And you want 4x cubed. 2. No tricks here, kids. And what's b got to be? Minus 3 times what gives me minus 3? Positive 1. Catch it? All right, that was our warm-up. We stretched. Here we go. I sometimes forget that it takes you a little bit longer to write it all out because I just copy it. I think finding A and C should be able to be done really quick, okay? Because A that times that, what's our coefficient of x cubed? 1. So x times ax squared, well, a has to be 1. Looking at C, right, don't do it in alphabetical order, go straight to C. Minus 5 times C has to equal minus 40. If you really want to write that down, go for it. So minus 5C has to equal minus, not a fan of the thick, has to equal minus 40. Agreed? So therefore C has to be 8. All right. Here comes the hardest bit, which I don't actually think is that bad. You feel free to disagree with me. Orange. Okay, I now choose the next one. So I choose x squared. All right, what's the coefficient of x squared? On the left-hand side, it's 1, correct. So I pop the 1 here, and now I go about trying to suss, how do I get x squared on the right-hand side? Well, the only way I can get x squared is x times x, and how else do we get x squared? Yep, Tom? Right, minus 5 times ax squared. So x times bx, that's a bx squared, so I've got a coefficient of b. Remember, only use the coefficients. When students start putting in the a's and the x's, we're just looking at the coefficients. And downstairs it's minus 5a x squared, but what is my a? So minus 5 times 1, minus 5. Can we now solve for b? B is socks. Socks. If I was putting this as a test question, I would follow that up and say, hence, find all the zeros of this cubic polynomial. And why should I expect you to be able to do that? Well, because what you've just told me is x cubed plus x squared take 22x take 40 equals x take 5, 1x squared plus 6x plus 8, and I can either factorise this, and if I can't factorise, then I would use the quad formula. Can you factorise this? Two numbers that times together gives you 8 but adds up to be 6. 2 and 4. So x plus 2, x plus 4, and hey presto, you've now given me the x-intercepts, the roots, the solutions, the zeros of a cubic. Well done. 5 minus 2 minus 4. Now this question is not asking you to do that, but this is where it's leading. Yeah? Grab your calculators. We've looked at this once before. Right, polynomial, instead of going to degree 2, we will go to degree 3. Pop in your values here. 1, 1, minus 2, minus 40. 1, 1, minus, oh, I forgot, minus 22. Minus 40. 5 minus 2 minus 4. Okay? Sorry, forgot you. Just done everything the same. We've gone, ooh, ooh, ooh. We've got a K instead of a number there. And we've gone, we haven't used this because we haven't needed to in all the other cases, but this time we're going to need to. So we do the same thing. We go x. What is the coefficient of x on the left-hand side? Insulting question, you can all see. Minus 7. What are the coefficients of x on the right-hand side? So how do I get just plain old x on the right? Well, 5x times the constant, so that's going to be 5c. Do I get just a plain old x any other way? 2b. Now, I know C, it's minus 3. So I've got minus 7. 5 times minus 3 is minus 15 plus 2b. Can you solve for b? Enjoyed my trip. You can solve for b. Once you've got b, sub it in here, and then you've got k. Nice? Nice. So let's make sure we're using our class time, because homework I want you to just spend on your investigation. All right, so for B, decide whether 3 is a 0 of. How can you work out if it's a 0 of something or not? I want you, and there's various options that we can do. Eyes this way. Decide if 3 is a 0 of that quadratic. How can you do that? What do you mean? So factorize. He said sum and product. So factorize. Yeah? How else could you do it? What's the whole point of when you find a 0 or an x-intercept or a root? When you sub it back in, what should you get? Oh, yes, 0. And this is where my heart breaks sometimes, because you guys don't get that. So if I've got x squared, give us a number, any number. Okay, we're going to go plus 2, and so minus, I was thinking 7, but not for the reason you're going with. No, I'm going to go with 8, right? And I'm saying equals 0. Now you factorize this. We factorize and we go, okay, what two numbers times together gives me minus 8 but adds up to be 2? Alex, you need to watch this. Stop looking at your laptop. Ooh, so plus 4, take 2, would we agree? So this is what you've done all the time. You go, oh, ha, ha, ha. Therefore, x is minus 4 and x is 2. Well, the whole point of doing this is that it looks here at minus 4 and at 2. And so at this point, when x is 2, what's your y value? 0, right? When you sub this back in, what is 2 squared plus 2 times 2? Take 8. It better equal 0. 2 squared is 4, plus 2 times 2 is 4. Take 8. Yeah, baby, that equals 0. And you will also say that it equals 0 if you sub minus 4 in, and those are the only values that it will work for. So, when we come to this one, absolutely, you can go, oh, I could factorize and whatever, or you could just sub. When you sub it in, if it equals 0, huzzah! It's a 0, or a root, or a solution. On your calculator, absolutely. If it doesn't equal 0, if it equals minus 1, if it equals 2, well, just double check your subbing. And then, no, it's not a 0 if it doesn't equal. Does that make sense? That's key in our understanding of what these are. Question 3. I'm under the pump. Find the roots of. How do we find the roots of? Factorize. If you can't factorize, quad formula or complete the square, but who wants to do that? Nobody. And if it doesn't say algebraically, what would you do? Go calculator, right? Make sure you start reading these questions. You should be able to do them by hand or with technology. Oui? So we will stop there because you're packing up. I wanted to try and finish this bit, so we are going to have to make sure we come Thursdays and Fridays using our lesson time really well. And then we're not going to be put under the pump. But can you see how this work is repeating itself and it's helping you revise earlier stuff? So we're on track.